So regular polygons have some very cool properties to them. So here we have a regular polygon. I just have it drawn here, but because it's regular, we know that it's going to have all congruent sides and all congruent angles. All right. And if we count the number of sides here, we have 1, 2, 3, 4, 5, 6, 7 sides. So in this case, since we have 7 sides, we can remember that this is called a heptagon. So now some properties about this diagram here. I'm going to find my center. So here's the center, let's say. And I'm going to make some segments from the center, and we're going to look at what they do. So one of the segments that we just talked about was the apithom. So the apithom is a segment that's going to go from the center. It's going to go perpendicular to the opposite side, and it also bisects that opposite side. So those two would be congruent. That apithom also will bisect the central angle. So if I draw the central angle in here, so here, this segment from the center to a vertex and the center to a consecutive vertex, this angle right here, that is the central angle. So I'm going to write central angle on the side here, and that's blue. So that apithom will bisect the central angle such that then this angle on the left here is congruent to this angle on the right. That central angle then also will bisect the interior angle of the regular polygon. So we can see here where this central angle segment, the one ray of that angle, intersects the vertex of the polygon here. That angle's ray is going to bisect the angle of the polygon. So that means that this angle here is congruent to this angle here. Now, similarly, since it's a regular polygon, if we look at the other side here, this ray of the central angle also will bisect that angle of the polygon. And since those angles are congruent, then those are bisected into two angles that are congruent to the two that I just marked in purple. So some conclusions. The apithom is the perpendicular bisector of the side. The apithom is also the angle bisector of the central angle. And let's say the ray of the central angle bisects the angle of the polygon. So I could really draw this kind of blue triangle in each of the, with each of the vertices. So I can draw it here, I can draw it here, I can draw it here, here, and here. And so now, how many central angles do I have? So we have 7 sides. And if I see here, I have my 1, I have 2, 3, 4, 5, 6, and I have 7 central angles. So 7 central angles. So each of those central angles adds up, and that would make an entire circle. So if I start right here, go all the way around, if I add up all those central angles, it's going to give me an entire circle. So I know that all the way around a circle is 360 degrees. So that means that one central angle is going to equal 360 divided by n, where n is the number of sides, because the number of sides we just showed, 7 sides, 7 central angles is equal. So the one central angle can be found by doing 360 divided by n. And these are some cool properties of the regular polygons. So on the VTP, we can fill in the area now of a regular polygon. The area of a regular polygon can be represented 2 different ways. The first way is area is equal to 1/2 of the apithum times the perimeter. And so I'm just going to put A equals right there as well. So if we think about what that means, the perimeter is the side length times the number of sides. So the other way to represent it is 1/2 times ASN. And if we think about how that works, we can look here at our diagram. And if I were to find the area of one of these triangles, so just this yellow triangle right here, then each of the triangles that I would make with my central angles, each of these blue triangles would be congruent to the one that I have in yellow. So the area of a triangle is 1/2 base times height. So the area of one triangle would equal 1/2. Well, the base here, this right here is the base. That base is the side length. So 1/2 the base times the height. Now the height we can see right here is the apithum, 1/2 S times A. Well, that's the area of one triangle. And so then the area of, oops, I'm gonna use a different color. The area of the polygon would just be that area of a triangle times 6 in this case, but it would be times the number of sides. So 1/2 times N times S times A, and that gives us that same formula. Just have the N, the S, and the A in different order. So N times S times A is the same as A times S times N. So let's look at a couple examples of putting the area to get to use. So example number 8, it says find the area of a decagon with an apithum of 7 inches. So I'm going to draw in my apithum. My apithum goes from the center. It is perpendicular to one of the sides. And we also said that it will bisect that side. So let me put a little tick mark and a tick mark because those two are congruent. It says that that apithum is 7 inches. So this is 7 inches. Now I can create a triangle from that, and I will create my triangle using my central angle, and then we're going to look at how can we find the other measures of the side length that we need. So creating my triangle, I can draw in the central angles triangle here in red. And so now I want to look at that central angle. So if I were to make all of the triangles here, I would think about how many of these red triangles would I have. Since it's a decagon and a decagon has 10 sides, then you're going to see that I will have 10 triangles. So that means, let's find that central angle. So the central angle would equal 360 divided by n. So n in this case is 10, so it's 360 divided by 10. So the central angle measure is 36 degrees. So each of these angles in here is 36 degrees, each of those red angles. And then once we drew the apithum in, the apithum bisected that angle. So what we're going to be using is we're going to be using half of this red triangle here, what I just drew in yellow. So let me draw that in yellow separate. I'll just draw it right down here. So there's my apithum. I'm going to draw it bigger here. So that's the yellow triangle. And so we know that this apithum is 7 inches. And then we know that the central angle was bisected to give us then that this angle inside the triangle is going to be half of that 36 degrees. So that is 18 degrees. And now what we can do is we can use our trigonometry to find the length of this segment here of the triangle, the purple one. So if I'm using the 18 degrees, this is the opposite side, and the 7 is the, adjacent side. So the trig function that uses opposite and adjacent is tangent. So we have the tangent of 18 degrees is equal to opposite, I'm going to call it x, divided by the adjacent, which is 7. So I can put this over 1 here and cross multiply to get x equals 7 times the tangent of 18 degrees. And then I can use that on my calculator if I would like to calculate it, but I actually don't need to. So that's how much x is. Now, what I want to know is how long is this entire side length? So the entire side length is not just that part, but it's double that. So that would come all the way over to here, right? Because these are the two that are congruent on the big diagram. So that means that the side length is going to be 2 times x. So it's 2 times 7 tangent of 18 degrees. Okay, so now to use my formula, the parts that I needed, I have. So my formula is the area is equal to 1/2 number of sides times the side length times the apithum. So 1/2 times, I have 10 sides. The side length is 2 times 7 tangent of 18. And then times the apithum, which is 7. And now I'm ready to plug this into my calculator. If you want to cancel the 2 and the 10 and make it into a 5, you can do that. And then you type it into your calculator. And so when you type it into your calculator, you have 5 times 2 times 7 times the tangent of 18, close that parenthesis, and then times 7. And what you should end up with is the area, I'm going to go back to my blue pen, is approximately 159, let's round to the nearest tenth, 0.2 inches squared. And that's the area of my regular polygon. Let's do one more. This one's even more special. This is the area of a regular hexagon with a side length of 10 centimeters. So a hexagon is even more special, and you'll see why when we find the central angle. So first it tells me the side length is 10 centimeters. So I'm going to go ahead and put that on my diagram here, make it blue. This whole blue is 10 centimeters. So again, I'm going to want to have drawn the apithum, and I then need to find that apithum. So there is my apithum, and I know that my apithum is perpendicular and it bisects that 10 centimeters. So I will now draw in the central angle. So let me change this color here, and let's make a central angle. We'll make that green. So the central angle here, let's say the central angle is going to be 360 divided by n. So that's 360 divided by 6, which is 60 degrees. Oh, that's interesting. So when I find that central angle, which is 60 degrees, that whole thing here is 60 degrees. So again, I'm just going to look at half of this triangle right here, that yellow triangle. Let's go ahead and redraw it. I highly encourage you every single time to redraw that triangle so it's a little bit bigger. And I know that that central angle got cut in half, and so that the angle at the top of this triangle now, if I do half of this 60, that means that this is 30 degrees. And that should ring a bell. So this is a special triangle, because if this is 90 right here, this other angle has to be 60. So that means that this has the formula, you guys remember, from 30, 60, 90 triangles. So this is S, this is 2s, and this side is s square root of 3. And so now look at our diagram. Let's see here. I have this 10 centimeters for that whole length. Well, then this part is going to just be half of that. So that means that this s is going to equal 5. So that means the hypotenuse is 10, and this side is going to be 5 square root of 3. So that 5 square root of 3 then right here, this is the apithum. So my apithum is equal to 5 times the square root of 3. All right, I think I have everything now to find my area. So the area is equal to 1/2 NSA. So that's 1/2. We have 6 sides. The side length is 10. The apithum is 5 square root of 3. And you actually don't even need a calculator for this one. I can reduce the 2 and the 6, make it into a 3. And then I have 3 times 10 is 30, times 5 is 150, square root of 3, and this is centimeters squared for my area. And that's how we could do a regular hexagon. Now that will always end up being a 30, 60, 90 triangle because your central angle is always 360 divided by 6 for a hexagon.